Welcome to Notes 8.03. Today we're going to look at application problems using our trig functions. So reminder, sine of an angle equals opposite over hypotenuse. Cosine of an angle is adjacent over hypotenuse. Tangent is our opposite over adjacent. A little vocabulary we'll look at is an angle of depression or an angle of elevation. So looking at our picture, we have a little birdie sitting in the top of a tree, and we have a dog down on the ground. Typically, at bird's eye level would go horizontal, but if it's looking down at the dog, that's going to be angle of depression. Let's say that measure was a 30-degree angle. Similarly, if that dog is looking up at the bird, its angle of elevation would be going up to the bird is going to be equal. So angle of depression would be something from the top looking down. An angle of elevation is going to be that looking up. And they're going to be equal to each other. So angle of depression and angle of elevation are always equal. Moving down to exercise 1, we have a lighthouse in Cape Hatteras, North Carolina, is 200 feet above sea level. If it spots a boat at an angle of depression of 28 degrees as shown, what is the horizontal distance of the to the base of the lighthouse? And what that means is how far is that boat going to be from the base of the lighthouse? So that's the measure we're looking for. The other digit they gave us was 200. That's going to be the height of the lighthouse. So here we have our right triangle because the lighthouse should be perpendicular to the sea level. And that angle of elevation angle of depression, they told us, is outside of the triangle that we have. So there's two ways to have done this. Some of you are going to see that 28 and this angle up here make 90 degrees. You could subtract from 180, but I'm going to do it a little bit simpler and pull that 28 degrees down as an alternate interior angle into the angle of elevation if I was in the boat looking up to the top of the lighthouse. So from here, we know we have from that angle the opposite side, we have the adjacent side. There's nothing next to our hypotenuse, so we're going to use opposite adjacent tangent. So tangent of the angle 28 degrees equals the opposite side 200 divided by our adjacent x. And when cross multiplying here, we know we need to put this over 1. So we have x times tan 28 equals 200. And then we divide by tan 28 to both sides. So in our case, x will equal, I'll show you here on my calculator. When we type in 200 times tan 28, we get 376.14529. And they're asking us to round to the nearest foot. So we're going to round to 376 feet. Moving down to exercise 2. To determine the height of a tree, loggers will measure the angle of elevation to the top of the tree and set a distance from its base, a set distance from its base. If the logger's eyes are 5 feet 3 inches above the ground and the angle of elevation is 38 degrees here, when standing 20 feet from the base, determine the height of the tree. So that's very wordy, but what they want is the height of the tree, and there's another key word here that we're going to have to be careful with the word problems, nearest inch. So we're trying to find the entire height of our tree. Now the tree has the top of the tree and the bottom of the tree, and that guy of 5 feet 3 inches is going to be important here. But the key piece I want us to focus on for now is that it's asking for everything in inches. Now, they gave us two different measurements in feet. So what we're going to want to do is convert to inches first. So 5 feet 3 inches is going to be 5 feet times 12 inches in a foot plus those extra 3 inches. We know 5 times 12 gives us 60. So his whole height here is going to be 63 inches. Now we're not going to need that until the end. And I'm just going to kind of bounce that over here as like part of the rectangle, the opposite side. Our 25 feet, if we take 25 times 12 inches, we get 300 inches across. So here for a right triangle, we're actually going to focus from his eye level over and up gives us our right triangle. So if it's 300 inches over, now from here to here, I'm going to mark this as a Y because 63 we're going to add in after the fact. So if I'm looking at the opposite side being this portion of the height of the tree from here to here is Y, we have a trig function from our angle. We have the opposite side and the adjacent side again. So we're going to have tangent from 38 degrees equals the opposite, and I'm going to use my Y, over 300. So when we cross multiply, Y equals 300 times tan 38. And into our calculator, 300 tan 38 will give us, sorry, I'm doing this backwards here, 234.3856. Now those 4 decimal places, the 3856 is going to be important. So let's write that down. So we have 234.3856. The reason those decimals are important is some of these word problems we're going to need 2 answers to add together, and these significant digits might affect your rounding. So when we need to go to the nearest inch, that's only the height from the top of the tree to like the middle of the trunk. We're going to add in this 63 inches now. That accounts for his height as he was looking to the top of the tree. So when we add 63, we're going to get a total of 297.3856. So our final answer here, that 7 is not going to increase for our rounding. Our final answer is going to be the height of the tree is 297 inches. Moving to exercise 3. This one doesn't have a picture given to you, so you're going to have to draw your own. We're talking about Bob. He is placing a ladder 6 feet from the base of his house. So let's draw a window. Here's his door. You can get fancy. But what he's doing is his ladder, colors is set up against a house. So Bob places an 18-foot ladder 6 feet from the base of his house. So the ladder is 18 feet, is going to be our hypotenuse, and it's placed 6 feet from the base of the house. Find to the nearest degree the measure the angle the bottom of the ladder makes with the ground. So here we're looking for the angle measure. Well, from the 2 sides they were given, we have our adjacent and our hypotenuse. So we're going to use cosine of the angle made with the ground equals adjacent 6 over 18. Now typing this one into the calculator, make sure you use second cos. So looking here, second cosine of 6 over 18 will give you 70.528. So let's write that down, 70.528 And rounding to the nearest degree here, we are going to bounce that up. So 0.5 will bounce us up for our answer to be 71 degrees. Moving ahead to the next side, overlapping triangles. Some steps for these overlapping triangles, we are going to first redraw our right triangles. So these diagrams are going to be two triangles that kind of overlap, and they're going to share some measures. So you have to really be careful with them. Then you can set up a trig function. And lastly, you always want to reread the question. Make sure you are answering what they're asking for here. So looking at exercise 4, and I know some of these questions are really silly, but just bear with us with these examples. You are a block away from a skyscraper that's 780 feet tall, so that's marked for you. Your friend is between the skyscraper and yourself. The angle of elevation from your position to the skyscraper is 42 degrees. The angle of elevation from their position is 71 degrees. So this diagram is kind of drawn overlapped. But how I would break it down is we have a diagram from you to the skyscraper, which is 180 feet tall. You're making a 42-degree angle. Then separately, your friend is going to have a skinnier triangle here, has an angle of elevation of 71 degrees, and that skyscraper is 780 feet tall. Now, what are they asking for? To the nearest foot, how far are you away from your friend? So going to the big diagram, they're asking for the measure from here to here, from you to your friend. Now, that's not a side of either of my triangles. My one triangle has a measure from me to the bottom of the skyscraper. I'm going to call that side A. So the whole measure from me to the skyscraper is going to be side A. So I'm going to mark that on the first right triangle. Then our friend is from here to the bottom of the skyscraper. I'm going to mark them part B. So we really have a couple measures we're finding here. Now, if we know A, which is, let's say it's going to be 100 feet away, and B was 20 feet away, X would be that difference. So at the very end of this question, what we're going to do, and I'm going to write this down here, is that X equals the value of A, the longest distance away, subtract the shorter distance B. So now that I have two right triangles and I have enough parts drawn, we're going to set up our trig function. So from 42 degrees, we have the opposite side is 780. A is going to be our adjacent. So we're going to use tangent of 42 equals 780 divided by A. Now, a little trick with this, when A is in your denominator, your variables in your denominator, you're really just going to flip-flop these. So A will equal 780 divided by tan 42. So typing that into our calculator, we get 866.2777. So I'm going to write that decimal down carefully here. It gives me 866.2777. Right. The next answer, we're going to do the same thing, but with our other triangle. So looking for side B, again, we have opposite, we have adjacent. So we're going to have tangent of our 71-degree angle for our friend equals 780 over B. And same case in the calculator, B will equal 780 divided by tan 71. Now again, that's a little clue. When your variable is in the denominator here, you're just going to really flip-flop those positions so that b goes in place of the tan 71, and tan 71 goes down to that denominator. Kind of fast forward some of our division. So 780 divided by tan 71 is going to give us 268.5755. So we have again 268.5755. Now, in our calculators, as I put it away, you can subtract those very easily. If you arrow up, sorry, I'm trying to do this upside down. If you arrow up to that to the 866 and highlight it, it'll recapture it on the next line. Then same deal if I get my 268. Now, what I meant to do there. So again, since I'm trying to find the difference, I want to capture the 866, which is my measure of angle I. So looking at your screen, I'm going to try to take angle side A and subtract side B. So 688.277 minus the 268 is going to give us a difference of 597.7 feet. So looking back at our paper here, the side X is the distance between me and the friend. So if I am 800 feet away or 860 feet away and our friend is 268 feet away, we're taking that 866.277 and subtracting our 268 with decimals. I'm running out of space. And our final answer is going to be 597.7022. So final answer rounded to the nearest foot is going to be 598 feet. Okay. So again, going through the steps, we redrew the two right triangles we had. So we looked from me to the tower, our friend to the tower, and we found our 800 and something and 200, and then lastly subtracted them. Okay. For now, I'm going to actually be skipping number 5. There's a little extra piece to this that I'm not going to stress us out about right now. But there's an example I have here that is not in your packets. So if you have scrap sheet of paper, you can pause the video, come back to this to try it with us. But this will help you toward a homework question. So looking here at an application problem. I don't know why this keeps showing up. So if you have a piece of paper and you'd like to resketch that big picture, please do. And again, you can pause the video to help yourselves. But I'm going to start reading. A person flying a kite originally lets out 232 feet. At this point, the person observes the angle of elevation to be 48 degrees. So there's our first right triangle. Is we have an angle of 48. And we know that the hypotenuse there, from there to the kite, is 232 feet. Then the person lets out an additional line for 258 feet and observes its angle of elevation to be 53 degrees. So there we have our two right triangles. So I tried to trace them as I was reading. If the kite rises vertically between points B and C, as shown, determine to the nearest foot how much higher the kite is at point C than point B. So what they're asking us for is the difference of B to C. So that's our variable, is how much higher it is from C to B. So what we're going to do again is redraw our two triangles. So the tall right triangle trying to keep the same colors here. Had that angle of elevation to be 53 degrees, and its line is 258 feet long. The whole height from C way down to that A that's marked in the first diagram, I'm going to call that part A here. When we redraw the second triangle, we have the shorter triangle had an angle of elevation of 48 degrees. The line was 232 feet, and that was the measure from B to A, and we're going to call that side B. So now that we've redrawn our two triangles, I'm going to set up our trig functions. And again, to find that measure of x, and let me explain it a little bit better this time, the whole measure from C down to A is what we dubbed as the A in our pink diagram. And then the measure B we have is from B to A down here. So again, if I had A as a whole segment and I knew B, I could subtract to find X. So we know that A equals X plus B. So if I needed to find X, I would subtract B across. So again, the measure of X that we're looking for is whatever A is, subtract side B, or the height of B. So again, setting up our trig functions, we have from the 53-degree angle here in the first triangle, we have the opposite and the hypotenuse. So we're going to have a sine function, sine of 53 equals A over 258. And that measure A in your calculator would be 206.047. 206.047. Because again, that's just a cross multiply case. To find the measure of B from our 48 degrees, again, we have opposite and hypotenuse. So we're going to have sine, opposite hypotenuse is sine, 48 equals B over 232. And 232 times sine of 48 gives us 172.4095. So the last step to find that measure of x is to take the difference. So if the kite up at C is 206 feet up, 0.047, and the height at B is 172.4095, okay, that difference is going to be our difference there is going to be 33.63. 33.63. Now, this is where you have to be careful of your rounding. It does go to the nearest foot. So 33.6 would round to 34 feet. There is a final answer. Okay, so that's another application problem. Taking a peek at the homework, I want to give you a couple clues. A lot of you have been listening great and using these clues to help yourselves. I really appreciate that. You guys are doing awesome with this. Can't wait to see you. So looking at the homework, the first page should be very self-explanatory and relatively easy to find out. Drawing your own pictures and so on. Looking at number 3, if I help you quickly with a picture, we're talking about the flagpole is 18 feet tall. So if we have our flagpole is 18 feet tall, remember a flagpole should be perpendicular to the ground. At a specific time of day, given the flagpole is set in concrete, that's perpendicular to the ground. Find to the nearest degree the angle of elevation. So from here, if I just explain, I did skip over a measure. I can tell right now 12 feet. So its shadow is 12 feet down here on the ground. And you're looking again for the angle of elevation. So if I'm standing here at a certain point on the ground, how many degrees up am I looking at would be your diagram for number 3. So again, make sure you're drawing that. Number 5, looking at that right triangle, and again, you would read the question, please. Bryce, the pilot, which I do have a friend, Bryce, who's a pilot, decides to give an update to his passengers as the flight's going. The plane has traveled 26 miles. So that's that diagonal distance out, and it's going 48 degrees north. Now, looking at the north, that angle 48 doesn't fall into the right triangle that they're doing over here. But with our alternate interior angles, we see that 48 can bounce up and be that angle of at the top of our right triangle. So another case with that is some students might see it as the 48 makes a right angle with the ground, would give you its complement would be 42 degrees for that angle there. So depending on which angle you focus on, you could use the sine function or the cosine function and be all right. Number 6 is that overlapping triangle idea. Now, what I would suggest is again to redraw your 2 right triangles, the small one and then the taller one. Okay. Now, what they're asking for at this question is the height of the sign. So, how tall is the sign from the top of the sign on the building to the bottom of the sign there? So, if that's the measure X we're looking for, we're going to have the whole height with the building and the sign being our A on our taller right triangle. And same deal with the height of just the building, we could call that B on the smaller right triangle. And again, very similar to how I set it up in the notes questions, X would equal the whole height, A, subtract the height of the building, B, and that'll leave you with just the height of the sign. So hopefully that helps. Email me with any questions. And again, thank you for your understanding. Oh, I'm hiding in the corner there. Sorry about that.